Hi, I'm Joe Feeks, editor of Pig Health Today, and with me is Dr. Michelle Soupir. She is Associate Professor in Agricultural and Biosystems Engineering at Iowa State University. Thanks for joining us today.
Thank you for having me, Joe.
Now, antibiotics get a lot of headlines. People are concerned about resistance. We've been talking about the veterinary feed directive this year. As an engineer, you've been specifically looking at antibiotics and their impact on the environment. What are you learning?
Well, we've been doing a couple different studies. First of all, we've been working at kind of a 1 acre plot scale. And at that size, we have a really controlled environment. And so we're able to see at a small scale what the impact of manure application is on the transport of antibiotics and antibiotic resistance to subsurface drainage waters.
So your concern is that antibiotics that are fed to swine, which of course end up in the manure, which then end up somehow in the groundwater? Is that what's going on?
Yeah, well, we really look at subsurface drainage water. So across much of the upper Midwestern United States, we've installed a network of tile drains in order to lower the water table. If you were to go back to much of Iowa 200 years ago, you would see a prairie and wetland system. So we have very hydric soils which hold water close to the land surface, and that just doesn't work for crop production. And so by installing these pipes underneath the ground, we lower the water table a couple feet, and that keeps the soils aerated, and that makes some of the most productive soils in the world for producing crops, especially corn and soybeans. And so then this shallow drainage water is discharged to nearby surface waters. And so we're really looking at kind of this accelerated transport through a pretty shallow soil profile, about 3 to 4 feet, and then the water hits a pipe and then is discharged to surface water. So it's quickly exported to surface waters.
So was there a particular incident or development that prompted your research to take a harder look at antibiotics in water?
Yeah, so in the past I had really worked a lot with the fecal indicator bacteria, E. coli, and Enterococcus. So those are organisms that are important for protecting public health. If an FIB is found in a water body, then at certain levels it could prompt a beach closure. So it could mean that the water is not safe for recreational use. From that, kind of the next natural step was to start looking at some of these organisms and to see if they're also resistant to antibiotics, especially in areas that have an influence from animal manure.
And what have you learned?
Well, so far we found that time after manure application is really important. So if the manure is applied in the fall and there's not a big rain event, there's all winter for those resistant organisms and those resistant genes to die off, and those concentrations can really be reduced. Within a year after application, we usually see that the organisms are back to background levels. So it does take a little bit of time for the concentrations of the resistant organisms to get back to those background levels. About a year is what we're seeing. We're also finding that the cropping practice is important. So in a corn on corn situation where manure is applied every single year, we can see higher levels of resistant genes in that drainage water than in a year where we have a corn and soybean rotation. And in fact, when we look at a corn and soybean rotation, we did not see a statistically significant increase in resistant genes in the drainage water.
You expected to?
We did because of the influence of manure, but we didn't. And so that we felt was really encouraging news for the industry.
Now, are you targeting certain kinds of antibiotics in your research?
Yeah, absolutely. So we've worked primarily with the macrolide tylosin. Tylosin is not an antibiotic that you or I would ever receive a prescription from the doctor for, but it's also in this class of antibiotics which are important for human health. So the most common is probably erythromycin, which you and I have both heard of at least. And so we've worked primarily with tylosin, and at least before the veterinary feed directive, we could always detect tylosin in our manure samples. We'll soon be looking at tetracycline also, but we expect to see less of that and see that less often.
So obviously your research is very technical. You're an engineer by trade. What are the takeaway messages for the pork industry, specifically for veterinarians who are prescribing these antibiotics and for producers who are ultimately using them?
So we've also been looking at some manure mitigation strategies. So what are some ways that the manure can be treated before it's applied to the land? And so from that, we're looking at some different options that perhaps could be used as a mitigation before the manure goes onto the land.
Now, there are other types of fertilizers that producers could be using. Have we looked at maybe giving up on manure altogether because of this concern?
Well, I think that there's a lot of importance to still appreciate the benefits that manure has for slower release of nutrients, a positive impact on soil health, the organic matter that it adds back to the system. In some places, there's increases in crop yield when we use manure. So there are a lot of positives to manure, and so I don't think that's where we're headed. I just think that with careful implementation of the VFD, perhaps adding some different mitigation strategies either before the manure goes onto the ground, or we're also, are there some things that can be done at the field level, like maybe corn and soybean rotation instead of corn on corn. And also manure application timing. That late fall application seems to be a good option because there's a lot of decrease in resistance that happens over winter.
And what about in spring? Have you taken a look at the impact of using manure in the spring?
Yeah, our latest project funded by the National Pork Board, actually, we are looking at 3 different manure application timings, a spring, an early fall, and then a late fall. We're only a year into that, so we don't have the data yet to share as far as what the impact is of those different timings. But we do know that there's good benefits to applying in the late fall for nutrients as well as for bacteria die-off.
Now, you mentioned the VFD, or the Veterinary Feed Directive. The new rules kicked in January 1st of this year. There's a lot more veterinary involvement in the decision process now for antibiotics, and that's a good thing. Are you seeing anything in your research at this point that you could say, well, ever since the VFD kicked in this year, we're seeing lower concentrations of antibiotics in the groundwater?
No, not yet. I mean, I hope so. I hope, if we were to have this conversation a year from now, we would see some differences. But, the truth is that we only collect manure usually once a year. We did get a spring manure sample, and we just don't have the data back yet to support that. So, but I fully expect that we'll see less detection of the antibiotics, tylosin and tetracycline in swine manure. And then, of course, if those, even though those concentrations that we detect are very low, they still seem to provide enough pressure on the microorganisms that we would then see high levels of resistance in the manure in the past. So hopefully that will be different once the VFD rolls out and we see a change in antibiotic use.
And I know that your work has been strictly with tylosin at this point. You're going to do some work with tetracycline, but is there certain structural properties of antibiotics that may make them more troublesome than others?
Well, a lot of the environmental properties of the antibiotics. So some are quite mobile in the environment, so they don't sorb to that soil profile quite as tightly, while others, are very highly hydrophobic, so they'll sorb to the soil and they won't move off-site into water systems. So, sulfamethazine is another antibiotic that we've done a little bit of work with. But the fact is that antibiotics in the environment are really difficult to detect because they are present in such low concentrations. It takes very specialized lab equipment to even be able to detect the presence of these antibiotics. So but we usually can find the resistant bacteria or the resistant genes.
And are all antibiotics that are found in the environment necessarily from agriculture?
No, yeah, many antibiotics are developed from soil microorganisms naturally. And so that's been an important finding also, is that we were able to report with resistant genes kind of some baseline data, because some of our field plots had not received manure for 30 years, and yet we can still detect those resistant gene concentrations in those field plots. And so it's good to know that there's a baseline of natural resistance that's in the environment, and then we can see a bump up with the addition of manure from facilities that use antibiotics.
And lastly, what about hospital waste? I would think that there'd be a lot of antibiotics in that as well.
Yeah, the wastewater treatment plants have big challenges too, because of the use of human antibiotics by humans. Those are obviously going to have a more direct impact on human health because they are the same antibiotics that humans use. And that's why many of the antibiotics that we've depended upon in the past are no longer effective for treating, even minor illnesses because we've overused antibiotics in hospital settings too. So yes, it's very important to acknowledge the human source is very important. The agricultural source just covers a large landscape. There's large acreages of land that receive manure, so it's generated over a larger source. And it's more difficult to treat with discharge from a hospital or a wastewater treatment plant. We have a pipe, and we can design some treatment strategies to help mitigate before that discharges out into the environment. But with animal manure, it's spread across the land, and so it's a little bit more difficult once it gets out on the landscape to try and control it and prevent it from moving into waters.
Well, it's important research, and it's going to be fascinating to watch as the VFD kicks in. So hopefully you can come back next year and tell us more about what you're finding in the field.
Sure, I'd love that.
Excellent. We've been talking to Michelle Soupir. She is Associate Professor in Agricultural and Biosystems Engineering at Iowa State. Thanks again, Michelle.
Thank you.